Hi, welcome to our pre-calculus. Today's topic, proving an identity using fundamental trig identities, problem type 6. So we have gone through 5 of these, and this is somewhat similar to what we had before. Let's see how do we choose our strategy to do this problem. So here I have tangent minus cotangent over tangent plus cotangent. On the right hand side, I have sine and cosine. So one thing we can think of doing is to convert left hand side to sine and cosine individually. That means using the quotient identities. So here I go ahead, make a fraction. In the numerator, I make another fraction. And there I'll have tangent is same as sine of x over, of course, cosine of x. Step forward and subtract. Now I have cotangent. Cotangent is the reverse of this, which is cosine of x over sine of x. In the denominator, we are going to have the same thing, except that we are adding them. So I am going to come here. Let's see if it works. So I'll have sine of x over cosine of x, and then plus another fraction, cosine of x over sine of x. So what did we do? Let's see if the software allows us to do 4 substitution at the same time. We used quotient identities all the way through. So this should be okay. Let's see if you are passed through. So that was fine. Next, what do I think of doing? Well, I have fractions in fractions, so I want to take common denominator and simplify. So what happens here? I have sine over cosine minus cosine over sine. If I want to subtract these two, I make a fraction with a common denominator, which is cosine times sine. And to do that, I will have the numerator multiplied by a sine, so it becomes sine squared. This is going to become cosine squared. So let's see if we make a fraction. In that fraction, I'll make another fraction, and the numerator I'll have sine square of x, and then, excuse me, minus cosine square of x. In the denominator, I had cosine of x times sine of x. Is that right? Do the same thing in the denominator, except that it's going to be adding. So I make a fraction to do this portion. Sine times sine is going to be sine square. So let's write sine square of x plus cosine square of x, and the denominator of this thing again is cosine of x times sine of x. So what did we do? We just did algebra here. So I am doing algebra, and now I do another algebra, which is clean these denominators. Multiply by sine cosine, so these two denominators will go away. I'll have difference of sine and cosine and sum of sines and cosine here. So let's make another fraction. In the numerator is going to be sine square of x minus cosine square of x. In the denominator is sine square of x. X has to be down here, plus cosine square of x. So what did we do? we did another set of algebra. Next, we notice the denominator sine squared plus cosine squared, that's just the 1. So let's see if the software will be happy with the following: minus cosine square of x. This is, we are using Pythagorean identity, meaning the denominator is 1. So the numerator is all that survives, and by coincidentally that's exactly what's on the right hand side anyway. So it says you are all set. Let's try another one. So we have 1 over cosine of x minus cosine of x over 1 plus sine of x. We want to show that that is equal to tangent of x. So what do we do? There are two fractions here. Maybe we try to actually take common denominator and subtract them, see what happens. So I want to take a common denominator. So how do you do common denominator? Numerator times denominator of this minus denominator of the first one times numerator of the second one. So in the numerator I have 1 plus sine of x. That's from the contribution of the first fraction, and second one, cosine times cosine, becomes cosine square of x. Denominator, I'll have cosine of x times quantity 1 plus sine of x. Okay, so what did we do so far? We just did algebra. We just added the two fractions. Next, what can I see here? I'll see that I have 1 minus cosine square of x. So what does that remind me of? That's by a Pythagorean identity, that's just sine square, is that right? So I have 1, that's 1 minus cosine square, I write it as sine square of x. And then I have plus sine of x again. In denominator I have cosine of x times 1 plus sine of x. So what did we use here? We just used the Pythagorean identity. Well, we are getting closer. Numerator and denominator, you see I have 1 plus sine of x, and from numerator I can factor a sine of x. So what do I get? Let's go in the numerator, actually factor sine of x times, we are left with sine of x plus 1. Is that right? When you factor sine of x from this, we get sine of x plus 1. And denominator, I have cosine of x times 1 plus sine of x. What did we do? We just did algebra, nothing else. Now these two factors are the same, sine x plus 1 or 1 plus sine x, they're the same thing, of course. So I am gonna do simplification. So I have, what is left is sine of x over cosine of x, and that is another algebra step. Next, sine of x over cosine of x is just tangent of x. And what rule is that? That is the quotient rule. So let's see. So it looks like we are done. And the identities are becoming a little bit lengthier, and the number of steps are increasing. So again, I recommend you try through a whole lot of them. Use it do it on paper first, and when you are here, do one step at a time, and hopefully you get the hang of it. Identity is probably the sweetest topic in trigonometry. There are so many of these trig identities. It can easily fill up your textbook with just this type of identities or identities related to triangles and such. And the best approach to them is a lot of practice. Okay, so until next time, good luck and God bless.